The bad health state issues on all these hosts been resolved only by just restarting the network time protocol daemon, that is NTPD daemon, on all the hosts. That made the time to be in sync. I think you remember I have clearly mentioned that one while I was discussing about the steps that are involved in making up your cluster setup. You remember your date should be in sync. Date in the sense like including the time in sync. Why it needs to be in sync? If it is not in sync, then the timestamp for the blocks and all, even when you submit the job, which is going to be executed with the help of the task trackers and all, even while sending the heartbeats and all, there will not be any consistency. And that reflects the health state of the hosts that are there as a part of your cluster. That is the reason why this is a very important aspect in terms of the health of your hosts connected in the network. So usually what the system admin is going to do is going to set up a separate server locally to their network and maintain the time and all on that, and every host is in sync with that server NTP, network time protocol NTP server. But now in our case we are using the public one because we haven't set up any local NTP server. That is why we are using the public one. Anyhow, as this is connected with the internet, as it is connected with the internet. So usually in the typical environment, all hosts may not be connected to the internet and your cluster may not be in the internet. That is only within the closed network of the organization. Even you are able to access the cluster outside the office only through the VPN. You may not be able to access to the internet because we will not expose the Hadoop cluster anytime to the public. It is always accessible. That is why most of the times the Hadoop jobs are on-premises jobs. Work from home kind of thing will be bit rare because the cluster access from outside is usually not permitted because of the security aspects. Your entire organization, enterprise data resides in the HDFS, and this cluster should not get exposed. That is the reason why we will make this internal to the organization only. And that is the reason why most of the times Hadoop related projects are not being outsourced like many other projects. Hadoop related projects are not being outsourced. Maybe a POC kind of thing may be outsourced to some organization, but the production activity, if you are planning your own setup and all, usually that is not being outsourced. Or you will not be exposing your enterprise data to the external world in any form. Whatever the contracts you may undergo, still your entire historical and enterprise data, you may not be interested to expose it. So once that is been taken care here, all your hosts in the cluster, their health came, it became normal. All you are seeing in the green. But still, you are seeing some configuration issues. Say, for example, all the hosts you have, these many configuration issues. But if you go and see, you take HDFS, go and see there, see what is the issue here. Java heap size of name node in bytes is recommended to be at least 1 GB for every million HDFS blocks. Suggested minimum value is that. Suggested minimum value is that. So how we can rectify that one? You go to HDFS. HDFS is a service. in that all these are the roles. I go to name node and I go to my configuration. There is only one instance of this role in this service. We recommend you to make configuration changes on the service configuration page instead. That is the reason why we are compelled to go to that. It is showing there is one configuration issue. All these are the name node configuration properties, whatever you are seeing here. All these are the name node configuration properties. And you see here, you also can view here name node, the port, web UI port, SSL port. Yes, you see that. What is the current heap size of the name node? What is the current
It's
heap
2
size?
GB, 2.7.
Yeah. So because we have given I think 12 GB to this instance, out of which 2.7 GB of memory is given to the. Now I ask you, this is going to be the same issue with all the other things. Why you require Java heap size of the name node to be this one?
I mean, name node is the one which actually has all the information, right? All the metadata of the blocks.
Yes. Yes, you're right. But still, why the heap of this JVM should be this one?
Is it for any garbage collection?
No. Because you know very well that all these daemons are nothing but Java programs. You know that, right? Did I mention that during our discussion
Yes.
anytime? That is the reason why most of the times I say that you cannot have absolute administration when it comes to Hadoop. You definitely need to have knowledge, uh, some basics of developer knowledge also needed. Without that also can be maintained, but it is like, you learn something and you remember it, but you don't know why. You don't know why. Here if you see this JVM heap size, they are specifically mentioning should be minimum of this one, and for every million HDFS blocks 1 GB is recommended. That is what they are claiming. In what way your name node aspect is connected to your JVM heap size and all, we need to have the understanding. In what way? You know very well, all these, whatever you are seeing, all these daemons are basically your Java process. You take your name node, your secondary name node, your data node, your job tracker, and even your task tracker. All these are Java process which runs inside your respective machines where you have configured them. Okay. So this being a Java process, you know very well, every Java program runs inside JVM. This is what we call it to be virtual machine, which is capable of running Java programs. It exactly works. I think I've shown you, if I'm not wrong. If I'm not wrong, I've shown you that one.
Yes.
There is a startup of the JVM and the shutdown of the JVM and all. Right?
Yes. 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 Yes.
So it works exactly like when you run your Java program, it works exactly like how your operating system is going to work. There will be a startup, and there will be loading of the required things, and finally your Java program is going to load, and then finally a Java program executes successfully, and then finally you have something called shutdown. So during the startup of your JVM, you have 5 runtime areas. 5 runtime areas that gets created inside your JVM. The first one is called the method area. Method area is a place where all your .class files gets loaded. I don't know whether you have noticed that anytime or not. I see here so I'm compiling my program. So imagine that whatever I'm running now, see test.java. Got compiled, and when I execute this one got executed. But the same, if you see, when I say this one, it is telling loaded and all. Loaded so and so class from so and so path. But it is not telling to which part it is loading. It is going to load into the method area of your JVM. Like how these are called runtime areas, which gets created only during runtime. There is one more runtime area called heap. This is a place where all your object creation, the memory to your object creation happens inside your heap space. Now, coming to our need here, Java heap size of name node in bytes is recommended to be at least 1 GB for every million HDFS blocks. As I told you a number of times in the past, if you see closely, even you submit a job to the job tracker is going to internally communicate with the name node only to get the understanding, to get the information about where the blocks for the given path are located on the cluster. So name node is the one which has got the complete information. So whatever the information that the name node, information in the sense, the file system details, all these file system details are actually available inside your heap only. that file system image, FS image, the active file system image is actually present inside the memory. If it is present on your hard drive, then for every request and I go and read the data from the hard drive and I share the details, the request cannot be processed that easily. You understand the point what I'm sharing here? You understand the point what I'm sharing here?
Yeah.
If your file system image, that is what I'm calling, of course, file system FS image is always persisted to your hard drive only. And there is a path also been mentioned for that one. Your file system image is always persisted over here. But the same file system image is also present in your heap to instantaneously give the response to the requests made by different services running on the cluster. Every service directly or indirectly needs the name node file system details. The file system image that is maintained by the name node, those details are needed to every service directly or indirectly. If for every request, if I need to go to the hard drive, read the data and render the service is not possible. That is why the file system image is being maintained inside my heap itself. If this heap size is less, then what happens again? Swapping is going to take place between the heap and the external storage. See, if I keep the heap to be 2 GB, assume, but my file system image is more, then the data that is actively needed is being persisted in the heap, and the remaining thing is being moved to the temporary storage. Whenever needed, I go back and read it. It is as same like your file system on the hard drive only, but this is somewhat faster than that because this is been written by your program, not by the fixed storage at the predefined location on the hard drive. That way it is slightly better, but still the performance bottleneck will be there. In order to overcome that only, they have mentioned this is very important, the crucial factor for the name node. So as we know very well that we don't have those many millions of HDFS blocks as of now. As we know that, we can go and say not needed as of now is a message what I'm keeping, and I say confirm. When I do that, I'm suppressing that warning and I go to my cluster and I see, I think you noticed my HDFS warning which was there earlier is now gone. Are you able to understand my point, friends? The reason why we discussed all those things is to make you to understand that how that property, I can directly go and say suppress or, but why that is crucial and critical, I think you have understood now. Anything related to the name node is definitely very, very important. Of course, all the other daemons also important. It is not that I say that they are not important, but name node is more crucial because that is considered to be single point of failure. Make sense? Any questions to me on that? Fine. So whatever the warnings that you have, all these whatever you are showing, whatever you are seeing here, warnings in terms of the configuration, those can be fixed by you by going to the respective, you can see here, memory or commit validation threshold. Okay. Memory on a host data node 3 is overcommitted. The total memory allocation is 6.4 GB. I think 8 we have given, but out of 8, the host operating system and all left over. Then we have but there are only 7.7 gigabytes of RAM 1.5 GB bytes of which are reserved for the system. Are you following what I'm sharing here? So you can go Java maximum heap size are multiplied by 1.3 to approximate JVM overhead. So you need to actually go and make these changes to make these warnings. And I say here suppress for all the hosts. Then we see even that is also gone. I hope you are following with me, friends, what I'm trying to share with you here. Because I know what is the
So Srini, just a question. The other day you had a lot of issues, right, bringing up this cluster. What was the major
what
problem
issues
there?
are there? What issues are there?
No, the other day you installed everything on the cluster, but we were not able to bring it up, right?
No, we were able to bring it up, but that was a bad health on all the nodes. You remember, all are in the
Yeah.
critical.
So what was the main issue? What was the main issue?
The main issue, no, there is only one issue what is been mentioned in the beginning of the session. It is because of the inappropriate time running on different hosts. So when I restarted this NTPD, that is Network Time Protocol Daemon, NTPD, restarted on all the hosts, that got resolved. There was no other issue. There was
Okay,
no other
got
issue.
it. Okay.
That is what I mentioned in the beginning of the discussion. That's fine then, yeah. So you see here, that is where I was compelled to discuss this point again. That is, time should be in sync is a very important factor for your cluster. If there is a problem there, then it results in the bad health to the nodes, because your time sync reflects in different ways in terms of the timestamp to the blocks, heartbeat, and even in terms of the job tracker. When it sends, the task trackers need to respond. Everywhere we will have that issue. That inconsistency will be there. Not to happen on all the hosts, the time should be in sync. Then only you will see all. This is one of the reason. I don't say this is the only reason why your hosts will be in bad health state. There may be multiple reasons. This is one of the reasons. Let me go and see what is the problem with this one concerning health. Why concerning health? Okay, that's not a problem. So we try to add other services. So we try to add see this one. So you see, that's not right. So this is running, and I'll show you. One second. Yes. See this one here. Zookeeper service is none before. Now I make are you looking at this one, friends?
Yes.
Though it is been installed at the later stage, but you see, so because your HDFS service is backed by HDFS service, I am talking here, it is backed by Zookeeper. So your HDFS service becomes part of high availability. It becomes a part of high availability. Now been done. Now actions. See here, redeployment needed. That's not a problem. Yeah, I can do that. Yes. Restart the stale services. Now I think you have noticed here we don't have the option to select multiple services to be added to the cluster at the same point of time. You notice that? But whereas when I go in the previous mode, what I have shown you in the last session, I can do all the configurations at one on the maybe later on when you add new host to the cluster. You want to, depending on your need, you can. Usually we don't do that. All your services we set up only time to time. I mean periodically. We only add the slaves. We only add the slaves. We will not be adding. We will not be adding services. Rare. We'll add, no doubt, but not that frequently. In any production environment, we only will be adding the slaves time to time, maybe every month or every 15 days. We may be adding one or two nodes, one or two slaves, so that your storage can be increased depending on your need. So whenever you are bringing new hosts, as been shown by me, you go to the host section, add the new host, and deploy the required configurations on the respective machine. And before bringing them to the cluster, what needs to be done? I have mentioned those points. That is all been taken care by the system admin or the network engineer. And bring the nodes and keep it as part of the rack, and IP assigned and everything been done. Your job is only to deploy the respective services onto those hosts. That's it. You will not be doing all the preliminary or the prerequisite stuff. That is all been taken care. So done now, because this is the cluster restart, friends, here. That is the reason why you have that. The cluster restart. Why there are fine, not a problem. Let us wait for some time. That's not a problem. So we'll also see, I think slowly you are seeing those things will come back. You are adding one more service, that is your scoop 2. Probably this on my master. A repository database type there be all been specified here. Where lib scoop 2. You want, you can have a look at that. So here you have SSH root at the rate, what is that, master slash var. I think you see the scoop 2 there. Yes. Creating scoop 2 user directory. User scoop 2 user directory. All these services makes the respective users to be created. Create a scoop database. It is always good that you read this one so that you understand. And start your service, starting one roles on this service. It has got only one role. And so continue and finish. Tell me why we are doing all these things now? Why we are doing all these things now? We have done HDFS, then Yarn, then Hive, then Zookeeper, then now Scoop. We are doing all these services, right? So my ultimate goal is you also do with Uzi and then set up my hue. Now it is asking, select these set of dependencies for your new Uzi. Yes.
What's the difference between those two? One was with Hive and one is without Hive.
No, thing is, even the Hive services and all, because we don't have the other things now, that is also accessible to your Uzi server. Uzi service has got, it is a service at the top. Let this get installed. I'll show you the roles as part of the Uzi service. So in order to make your Hive also to be accessible to your Uzi, we are making Hive also to be a dependent service to your Uzi service. Yarn, HDFS and Hive, all the three. We are making as a dependencies for our new Uzi server. So this also I'm trying to set up on my master. Now see here, Uzi internally, whenever you are going to submit the jobs to Uzi, either they may be your regular Uzi jobs or your coordinator jobs which are going to run every day morning 5 o'clock if a job needs to run. I think, Aaron, you better understand. So How it is going to maintain all those details? It definitely requires its own database to store all these details. Configure and test database connections if using custom databases. Create the database first according to the installing and configuring an external database section of the installation guide, then only you do it. Now I am using the embedded database. You want, you can test the connection. It is saying that it can be done only at the later stage. Continue. Now it is starting. You have any difficulty? It has been, yes, creating Uzi database is done here now. Creating Uzi database is successfully done. Tables also been created. Create Uzi database tables. Also been created. You want, you can installing the Uzi Shared Library in HDFS. In the pseudo cluster, whatever is been set up on your box, if you want, you can go there and see. You go to your MySQL database that is running on your pseudo cluster, and you see show databases there. You'll be seeing a database by name Uzi, Metastore, Sentry, Rman. So all those are the databases that got created whenever the respective services are being set up and started on your cluster. Let it be pseudo cluster or a fully distributed mode. So all those databases are populated with the respective tables, and with those tables only your services are going to maintain the consistent information. Not every service needed, but most services require the database. Even you see your Hive, Hive internally maintains a metastore. Every table that you create at your Hive level, the details are being tracked in the metastore. So let me not go into the developer part. So there, every action that you perform against your Hive warehouse are being tracked inside your metastore. For that sake, your metastore database is created and the tables are created internally to that, and those tables are being used to track the information about your Hive warehouse. Every action that you perform against your Hive warehouse. Even same, when I am making my Uzi to be used as part of scheduling my jobs and all, then all those details are being tracked by Uzi. Otherwise, what jobs are being executed and what time they are being executed, and if it is a coordinator job, at what time that needs to be executed, all these needs to be persisted somewhere. Based on that only your Uzi server is going to periodically check and make the respective jobs to get executed on the cluster. So for that sake, database is needed. That is what is happening here. But that is being maintained with your built-in or embedded PostgreSQL database on this cluster. But if you want, you can configure your own. That is why the option is been given to you there. You can select that one. But before you select here, you need to make sure the database is created and kept ready there. Not like you stop here and you go there and do that one. When you are setting up the cluster and you want your services to use a separate database, not the embedded database, then you need to install that, keep that available, keep that ready. Then you can come here and make that enabled, select your own database, and your tables and all will get created in the database. So it's getting created. It is installing the Uzi shared libs in the HDFS. Create Uzi shared lib root directory, successfully done. Upload Uzi shared libraries. Because unlike your normal jobs, your Uzi jobs are going to run on the cluster with the help of Uzi server. Then it will not be able to access it will not be able to access the libraries present on your local file system. That is the reason why it requires its own library to be available at the HDFS. That is why it is creating that one and uploading all the libraries to the shared library under HDFS only. There is a reason for everything that is happening at this level, whatever you are seeing. But we only need to have the patience to understand all those things. You got the point here why in the case of Hive and in the case of the other services that we did, this didn't happen. Which one didn't happen? Creating Uzi Shared Library, and that is getting uploaded. Why that is required only to Uzi?
Because it's used by other services.
Not other services. If you see, Uzi jobs are a sequence of MapReduce jobs, basically. I mean, how you develop a Uzi job is, you are going to have a bigger task as a requirement, something like, in order to achieve or fulfill that task, you may need to have a MapReduce job to do the massaging, data massaging, and then a pig script to run for the sake of some transformation, and maybe a Hive query needs to run, and finally a scoop command, not query, basically here a script again, and a scoop a command to actually export the data to your traditional RDBMS. All these needs to run in a sequence. The output of MapReduce job is consumed by the pig. The output of pig is consumed by the Hive. The output of the Hive is consumed by the scoop, which is actually been exported to your traditional RDBMS to the respective tables. And this is where I make use of as an analyst, using my BI tools, I'll be able to analyze the data. That is what my goal. And now, if these needs to be executed, what I do is I configure all these things as part of my XML file. That is a Uzi configuration file. And this XML file I submit to my Uzi server. Uzi server. What Uzi server will do is, it will take all the details from the XML file and run one after the other. Okay. When it is running all these in a sequence, whatever that you have specified, I require the libraries to be accessed. And those libraries, if they are present on the local file system, I may not be able to access them. That is the reason why all those libraries that are needed are actually being stored in the shared library under HDFS, so that your Uzi server able to access those things during the execution of the jobs to the server. That is the reason why, because in the other cases, if you see, friends, you are manually doing those things. You are going and running your MapReduce job, you are going and running or initiating your Hive-F, you run your script, Pig-F, you run your script, Hadoop ZAR, and you give the ZAR file and you run that one. That all you do it manually, I mean from the terminal. So it is capable of from where you are running, there if the libraries are available, I am done. I don't have any problem. But this is not the case. That is the reason why these are actually being uploaded to. One second, friends. Sorry. So that is the reason why these needs to be uploaded to your shared library. That is what is been done here. Upload Uzi Shared Library, successfully done, and your Uzi service also been started, and that is the reason why. Yes. Now I will have the comfort to add the service. What is the service? Flume you want? Yes, you can set up the Flume also. Let me check once. HBase I don't need at all now. I'll not be doing that. Impala probably. So Kafka I'll not be doing. Kudu I'll not be doing. Sentry, Solar, Spark. I'll not be doing all these things. Let me also. Even Flume I don't need, but we'll do that. Maybe on data node 4, I set up my Flume agent. Okay. So I have my Flume. Fine, it takes time to make all these things gets refreshed. That's not a problem. So now I'm going to add the service. What is the service that I'll be adding? I'll be adding my hue. Now here. See what needs to be. Select the set of dependencies for your new hue. Friends, I think you are able to understand now. The Uzi, even in terms of Uzi also, you noticed even in terms of Uzi, what we have as part of that Uzi server and Uzi hosts as part of the service. Now you take this Uzi server and you see its configuration. It runs on its own. It runs as a Uzi server database type Postgre, which we have already noticed. And then var log Uzi is the Uzi server log directory. Uzi HTTP port is 11,000. Uzi HTTP port is 11,000. Your Uzi server runs on, that is where it has got its own web UI. You want, you can see that here. Why it is not, no problem. I think this resolution is not happening. 192.168.159. I think we have set up this on master, that is 40. Oh, okay. Got it. Uzi web console is disabled. We need to actually install this extjs library. That's fine. So anyhow, we will not be using that through its own console. We'll be accessing through your Hive browser. So I'm adding the Hive service now. When I'm adding this Hive service, it is asking me set of dependencies. Now you need to decide whether you want a scoop 2 also to be a part of your Hive service or not. You decide. You want, you select this one. If not, you select this one. I selected this one and say continue. And I want my Hive server where it needs to run. It's good that it runs on master. Use embedded database again for this also. And here you see adding your is done. All Cloudera manager agents on the commission and the LD nodes are reporting. That is fine. Creating Hive database is also done. Created your Hive database. And now starting your Hive service. Once the Hive service starts, I will be able to, yes, it is also been done successfully. And I click on finish now. Now here, if you see this Hive, this I need to go with my 192.1. That resolution is not done on my Windows box. That is the reason why it is 159.40. I think you have seen here. Since this is the first time logging, pick any username and password. Be sure to remember these will become your Hive super user credentials. Okay. So what is that? I'm doing Cloudera and Cloudera. Remember that one, friends. Cloudera and Cloudera. Now I think you are able to access. Now with this, I think you got the clear understanding how this Hive service is available even as part of your pseudo cluster. Now you go and see here, in the query editors part you have Hive, Pig and all these things. And in the data browsers part you have Scoop also. In the workflows part you have your Uzi related things. I think you noticed here. Able to understand this one, friends?
Yeah.
Because that is what we have selected at the time of setting up the Hive service. When you're trying to install the Hive service, what dependencies need to be there to your Hive service, that all we mentioned. That's what we got here. That's what we got here. 1 second. Yeah, friends. So while setting up this U service, you have decided what this is one more administration again. It has got its own administration. Who need to be given access to this one? That all is again, this all is a development front. So you need to decide now. Cloudera and Cloudera, what we have done, we can add the user. We can add the username and create a home directory. If I check this one, then this is something like what I say, sample, and see here, I click on add user. Or you want, you can also make this to be a part of some group and all, that you can do it, otherwise not a problem. You can see that here, whatever you go to the HDFS browser as part of this view, you will be seeing under user you have something called sample. This is the home, like how in the Linux environment, whenever you create a user, the user will get a home. Same like even here. At the root level, we have a user. Under user, you have something called sample. Under user, you have something called Cloudera. So for every user that gets created, there will be a directory created here. And whatever you do as a particular user, all will get reflected over here. By default, when I logged in here, you can see that when I go to the file browser, so by default, I come into my, because I logged in as Cloudera, by default, I come to my home. So every action that you perform will be against this one. So here, you have the access to all these. You have the access to, you can do it from the terminal or you can do it from the browser, the Hue browser. So what services needs to be integrated into this one? We don't have any tables as of now. That is why we are not able to do anything here. So if you have any tables, then we'll be able to access those tables directly from here, right? This is how you configure your Hue service as part of your the cluster setup. Why there are concerning health issues? Let's see. Okay. This is because Zookeeper service, Cloudera suggests at least 3 servers for Zookeeper. So I don't need that one. That is why I'm suppressing that. I don't need that. So you might have noticed that how come all came in the healthy condition by just suppressing those warnings. Right? So even after setting up the cluster, you should be able to, add the required services and get the things done, right? So this one, I think you have noticed here that this is what so this is the only one that is available here. This is downloaded, distributed and activated. Now whatever the parcels that you require, you can download them and keep them. Whenever you want, you can distribute and make them active. You can see that here, you can download. We have downloaded only this one, CDH5, only that we have downloaded. you want, you can download the other things, whatever you are seeing here. You can download the other things. You may not, you need not distribute and make them active. You can download and keep them as part. And you also see the parcel usage, how each parcel is being used. You can see that here on the cluster, because I told you the same Cloudera manager can be used to manage multiple clusters, and how these parcels are being used on various clusters. You are seeing here cluster 1 and what is the product. Okay, and you see this is how it is been. I think you noticed here down host with CDH process running, you are seeing here on my data node 2, 3, 4, my manager and my master. So now all these, my CDH5 is running active on all the 6. That is what you can see how these parcels are being used. So depending on your requirement, because we will not be working anymore with the packages and all, we'll be working only with the parcels. I've explained you in detail why we go with the parcel compared to that package. So you download whatever is needed, and make sure when you're downloading the parcels on the manager instance, we need to have enough space. Of course, that will be there anyhow. Usually we are going to set up this manager on a usually on a high configured machine. So storage should not be a problem there, but it is only to make sure. You download the respective and make them available so that they can be distributed on whatever the host you need. And how you add new hosts to the cluster now. So we have 6 now here, and you see very clearly on this data node 1, what are the roles that are running. HDFS, Hive Gateway and Yarn are the 3 roles. And here also we have 3 roles. That is how I distributed. On my manager, I have 12 roles running. You can see that here. And on my master, I have 7 roles running. What are those 7 roles? You are seeing here. Right? So you want to add new hosts. You can click on this add new host to the cluster. I think now you understand where we are coming. Are you able to understand this one, friends?
Yeah.
Where we came? We came to the same place from where we started this one. Now, I don't have any more hosts to add here. Already there. Already all are there available here. But if I want, I can add. I can give the pattern. If you are adding 4 hosts now, you give the pattern there, and they have been identified, and your client configurations are going to be deployed onto those nodes. Hope you understand what is being done here. So whenever you are adding new hosts, you go to your hosts, and there you have the option add new host to the cluster. You can inspect the hosts. You can inspect the hosts. Runs the host inspector on all these whatever 6 hosts you have. It is showing what it is doing. Inspect a host ran successfully on this one, and checking all the details about that on the respective. And periodically you can check whether all the hosts are working as expected or not. You can see that here. You can see the results of that also. Okay. So that is one other thing. And the other one is, yeah, host parcels we have done. Yes. Now here. You can see how your roles are being distributed across your different hosts on the cluster. On data node 4 and data node 1 to 3, what are being done? Because on data node 4, you remember, I think I have set up my Flume agent. I think you remember. That is the reason why additionally it is showing this one separately. This is a Flume agent that I have set up. Data node, your gateway, then your node manager, Node manager, Hive gateway, and data node. If I haven't set up this Flume agent, then it might have shown data node 1 to 4, all these things. In manager, you have all these, how these are being, right? How these are being, you can get the understanding, right? So apart from this one, we need to have, yeah, 1 second. Backup part we see at the later stage. Yes. And administration also we see at the later stage. Audits that we can see. Audits I did not talk much. Every action that you perform is being recorded so that you will be able to see what has happened on your cluster. It has recorded everything here. I think you noticed. Succeeded command first run, created Flume service Flume, created a role Flume agent first run. This only, I mean, you want to can get more. Okay, the last 30 minutes. You want to have for the last 6 hours what is been done. Successful login of the admin, created the zoo, created service zookeeper, created role, first run of this one, and after that restarting has been done, created the service scoop, and then you see all these happening. Now for the last 6 hours, what is happening? You can get from the audits, which is also an important phase of important step of an admin to understand what is happening on your cluster. One other thing, though it is not needed, but if you want, you can have your own charts to be built. Your own charts to be built. Okay. So how you build the charts is based on what exactly you need. I think you are noticing here all these charts, whatever you are seeing, you see the cluster CPU, the cluster disk IO, all these are the charts that are being by default created and accessible to you. But other than this, you want any chart to be created, provision is being made here to create your own charts. You also can have your own dashboard even. You want to can create your own dashboard and assign the charts to your dashboard and monitor or manage only what you need. These are the default charts that are being created here. You want to can go to the open in chart builder. You can see that here. Select CPU percent across hosts where category equals to whatever the cluster is specified. So that is how you are getting this one. Of course, your browser itself is going to help you to get all those things. We need not learn this language separately. So that is going to help you. This is what the chart that you have there. That is the reason why you are able to see this one. What is a chart type and what is the title that needs to be given, the scale, all those things if you specify, you will be able to build your own charts. But for that sake, you need to have a requirement what you want to monitor. You want to monitor what aspects of the cluster you want to monitor. Based on that, you need to create your own chart. Not only the chart, you want, you can have your own dashboard also. You can create your dashboard even and add all these charts to the dashboard so that you will be able to monitor what needs to be monitored by you. But by default, all the required charts are being provided to you to make your CPU, IO, network IO, and even your HDFS IO all be. Not only this one, even you specifically go to any service, there we have the specific charts available again. What is HDFS capacity? Total bytes read across data nodes, total bytes written across data nodes. So you have separate charts available at every service level. At every service level. Apart from these, you need anything, then you can plan for your own charts by going to your charts creation, chart builder. You'll be able to build your own charts. Make sense, friends?
Yep.
So you see all the services now, including your cloud management service. Of course, there's some warnings we need not worry much. Warnings we need not worry much, but still they need to be taken into consideration. I don't say that we ignore them completely. Um, this being a non-production cluster, everything is okay. I mean, we need not worry. But if it is a case of the production cluster, we will not even leave these warnings also in terms of your configuration. Even those needs to be resolved properly. Otherwise, these may lead to any disaster in the coming days. I mean, may lead to the potential harm to the health of the nodes if not been taken care at the initial level, and over a period of time your host starts malfunctioning, and that will create a havoc in the cluster. If any host is not performing well, then the impact on the cluster will be very high, because immediately the name node becomes attentive and make all the blocks available on that host to be replicated on the other healthy hosts. A lot of work will be there in the background. That is where, as an admin, we need to make sure all your nodes are in the healthy condition. For any reason, if your hosts are not in healthy condition, the problem is not only that, if it is consistently not in the healthy condition, then the name node is going to decide that the blocks that are present on that host are being distributed to the other hosts. That is going to be taken care. So that will be an enormous load on the cluster. So we need to make sure all the health related issues are being fixed at the appropriate level. That's where we need to monitor. Of course, we are going to set the thresholds and all to every service, and once it reaches or nearer to that one, email is going to be triggered to the admin. At least with that, we'll be able to come to know that something, I mean, some attention is needed on the cluster now, right? So I cannot say, please go and practice like how I used to do it with the developer program, but at least we need to read the documentation associated with this one. I advise you to read the documentation associated. For every service, I personally advise that you go to the respective, say for example, if you are talking about yarn, if you need to learn something about yarn, I advise you to go to hadoop.apache.org. There you will see the documentation related to yarn, and I advise you to go through that documentation so that you can see that here. Yarn architecture and the capacity schedulers and the resource manager high availability, all these aspects, your yarn application security, node manager, and what is graceful decommissioning. So all these things you'll be able to see as part of the yarn. So I advise you to go through this documentation, not any specific. Even you go through any other documentation other than this, they're all the subsets of what you are going to read here. So it may be painful for you to read this much documentation, but yes, is needed at some level. Is needed at some level. Even you take here what is rack awareness, what is rack awareness, what is service level authorization, what is HTTP authentication. I think you are seeing all those things here. Even HDFS level, you see your HDFS architecture, what is ViewFS, what we mean by snapshots, what is image viewer, and permissions, and the HDFS quotas and your HDFS libraries. You see all that stuff here, right? I advise you to go through this documentation whenever you find time. I'm not putting any constraint that you need to do it in a day or two, but make sure that you go through this documentation. And most of this stuff is theoretical to make you to understand what each service, each role, and how we need to manage and monitor those services as part of your Hadoop cluster. When something goes wrong, how that can be fine-tuned or how that can be configured. to make it to work as per your expectation. So it is painful journey, no doubt, but I advise you to go through the documentation. Similarly, you want to see something related to Scoop. There also we have a scoop.apache.org again, and there if you go and see, we have both developer and admin documentation available. If you go to this one, it is going to show documentation as part Scoop user guide and Scoop developer guide, both the developer guide and the user guide. How Scoop can be used and what configurations needed, if at all. If Scoop doesn't need, because that is actually the tool to be used by the developer to export the data or import the data between your HDFS and your traditional RDBMS. So you have the documentation available here. So you can go through that one. Similarly, the same, even you see hive.apache.org, and there at least you see getting started, you see how your installation is going to be done as a service, and what is your Hive server 2, and what is the JDBC driver, and how Hive server is being made accessible to the external world. So you'll be getting all those things. You can see that here. Installing Hive from a stable release, how it is been. Of course, we are not doing through the manual mode like this. We'll be doing through your Cloudera manager only. So we don't need, but we get the understanding what services you have as part of your Hive and how those services are going to run. What is a Hive server 2 and Beeline? Beeline is the alternative to your Hadoop shell. I mean your Hive shell, where you're able to access your warehouse. So Beeline is a modern. Starting from Hive 2, you need to use your Beeline, not your Hive shell anymore. So you come to know all those things. Of course, these things we don't need. This all the developer part, how you run your Hive local mode and the MapRed mode and all that stuff. We don't need all those things. But what all needed as an admin in terms of installation, in terms of configuration, all those things, you can get it from the same documentation. Instead of you doing it through the other documentation, it is advisable that you go through this documentation. So that tomorrow, if any new release is done and any new role, not service, new role been added as a part of this Hive service, that you come to know immediately over here only. You will not be getting that stuff from your documentation, because all those written as a byproduct of this documentation only. So good that you read the documentation from the original development team, so that it will be more effective, right? So for every component, friends, I have shown you a couple of components here, Hadoop, Hive, Scoop and all. Even for Uzi also, we have the same, like uzi.apache.org, and you go there you will be finding even the documentation for the developer documentation and the administrator documentation. How you install Uzi and how you monitor and manage your logging and your Hadoop configuration, or your Uzi monitoring, and how the upgrades can be done. All those things you'll be able to see as part of this. So every component, they're all needed and required. You have both the developer and the admin documentation available. So it is advisable that you go through this documentation time to time, so that you can, of course, it is not possible that you remember every precise and minute details of every property of the configuration. At times it is needed. You should be able to immediately go there all. So this property indicates this one, and this has got this range of values to be given, and each range indicates this one, and based on that you decide what is appropriate value to be fixed for that property as part of your configuration. Where we are getting those configurations you will be seeing. You go to any service, you have something called configuration. So whatever you are seeing here in the configuration, you can get the details here itself, that is one way, but I don't want to go in this way. I want you to understand every property that is associated with the service from the respective technical documentation. Then only it will be more meaningful, right? So I advise you to go through that one, friends. So this is what I can at least tell you, yeah, because we are seeing very clearly what we are doing on the cluster, how you are adding the services to the cluster, and when it comes to the configuration, all these configuration properties are available in the documentation what I am showing you now. So I advise you to go through this. Maybe one day you can go through your Hadoop admin documentation, the other day your Uzi admin documentation. These can be independently dealt. Of course, you have the dependency that you know very well what we did here. So you want to go in the same path that is more effective, but you also can go through independently. That's not a problem. Usually you can go through it independently, seeing all the configurations and all. Make sense, friends?
Yeah.
So please go through that one. You have any questions to me for today?
So just one question on the adding data nodes.
Yeah.
So if I start to add, say I have a 4-node cluster right now.
Okay.
I'm going to add 4 more nodes to this cluster.
Okay.
But those are like high performance nodes. And the plan is I want to add those 4 nodes, and after some time I want to retire the current 4 nodes.
Absolutely can be done. How is you can make the roles, what roles you have set up. See, usually we will not be, that is what I mentioned it, Arun, if you remember correctly. So you are going to add only slaves most of the times. You are going to add only the slaves, not the masters, because those services you might have already set on the cluster. Okay. But still you feel those roles or those services need to be moved to the other one, yes, is possible. And you can make the existing one to get retired, right? That is what we do. Say for example, here I take this one. I take my data node 4, okay? So here I have the option. I think you noticed, you see the monitoring of this one. Actions here. Yes. So you can stop the roles on this host. You can stop the roles on this host, and then you can click on decommission that, so that you can take out that. Once you say decommission, then the name node will become active and see what blocks that are supposed to be on that node are being taken enough care to get replicated on the other available nodes. It's been taken care. Again, when you bring in 4 nodes, as you said, and you want existing nodes to get decommissioned, so it takes care of distributing the load onto the other nodes, and over a period of time you feel that the cluster is not well balanced. Then you have as part of the HDFS service, we have something called, I think you notice here, we have something called balancer. So using this balancer, you are able to balance the load on the cluster. That can be done. That can be taken care by you. That's not a problem. So as per your, if I've understood your requirement correctly, you add new nodes and you want existing nodes to get retired. So for that sake, you need to make sure that the roles, what you have defined on that, are being made available on the other before you make them to retire. And then you can.
So basically, after enabling all the roles on the new nodes, I have to give some time, right, for the data replication to happen before I turn down the existing, correct?
No.
Or can I instantaneously do that?
No, not needed. We can do it. We can decommission it because when you're decommissioning, you know, it has got the replicas on the other nodes, right? So a name node will take the one of the replica and do it. So it is something like one node down, no problem, right? Because the replication factor is maintained on the cluster.
Oh, okay, got it. Got it. Okay.
So that should not be a problem at all.
Yeah, but I cannot take down all the 4 nodes at the same time. I should give it enough time one by one.
That
Right?
cannot be. That cannot be. That cannot be.
Okay.
Then it is going to be a potential health. Yeah, Mani, you are saying something related to health? Fine, friends. Please go through the documentation, whatever I mentioned, time to time. That should be a consistent process to you. It's not a day job. And let me know you have any questions anywhere while going through the documentation. We can work on them.